So this is take number 728 of me trying to record this video over the nervous system. After these 728 tries, I finally figured out that it's not me, but it's actually Crestview technology that is causing me issues. So I'm recording this at my apartment. Things you might hear in the background that I can't help, and I apologize now. I live near a hospital, so you'll hear ambulances. Don't worry. I don't have corona. You might hear, here's my air quotes that you can't see, really cool people who think it's awesome to play their music outside my windows. Sorry in advance. You might also hear my cats. They're kind of obnoxious. But here we go. Nervous system, chapter 7, part 1. So with your nervous system, which is what we are starting now through this online learning, we are going to first look at the structural classification. So your nervous system can be classified two ways structurally. And one of the first things that people think about when they think of the nervous system is the brain. And your brain, in addition to your spinal cord, actually makes up our first structural classification. So our first one is the central nervous system, which in this PowerPoint and in your notes and in various assignments, you will see abbreviated as CNS. Okay? And remember that makes up your brain and spinal cord. Now the second structural classification of our nervous system is the peripheral nervous system, abbreviated PNS. And this is basically all of the nerves outside of the brain and the spinal cord. So if it's not a part of your brain or spinal cord, it is your peripheral nervous system. In the picture here, you can see central nervous system with your brain, and then your spinal cord, and then peripheral nervous system's over here, so it's basically everything else, including the nerves in your arm, in your leg, and your trunk. Now with your nervous system, so most people at this point understand that the nervous system is used to pass messages, but the details behind it are usually kind of foggy for people. So the very first step to your body reacting to something is that there needs to be a sensory input. And the sensory input, probably the easiest way to describe it is that this is how your body gathers information. And so you have a bunch of what we call sensory nerves, okay, that monitor changes that are happening inside and outside of the body. And anytime we see a change or a stimuli happen, that is going to be that first step to our body responding to it. Now, it can be something major, like a major stimuli where maybe you fall down and get cut. Okay, that would be kind of major. Maybe one of your organs goes into organ failure. That would be major. Or it could be something that really doesn't cause a whole lot of change. So maybe the sun comes out and your body has to adapt, like your eyes have to adapt to the amount of light or that light change. Maybe you walk into a really cold room and you get goosebumps. Okay, when you walk into that really cold room, that is one area where your senses send that message to your brain, and we'll go from there. Alright, so sensory input, basically we're collecting information from our inside of our body or the outside world. Now once you've collected that information through your sensory nerves, your nerves are going to take that message, whatever it might be, and head to the brain. Okay, so when it goes to the brain, it goes through this process that we call integration. And with integration, this is the brain's way of processing and interpreting that message from the sensory input, and it's also kind of deciding whether or not there needs to be an action, because sometimes your body has to react to things and sometimes it doesn't. And so it's at that point that your brain basically just says to itself, this is the message I got, do I need to do something about it? And then the last part, once your brain has taken its time to figure out what it needs to do or not do, if there is a response that is needed. A lot of times we will call this the motor output, and this is a response to the integrated stimuli. This response a lot of times activates muscles, but it can also activate things like hormonal glands too. So if we were to take an example and put this into the information on the slide, we'll use like the old example of like you touch something hot. Okay, so let's say You're chilling at home because you're in quarantine and you decide to make some mac and cheese. Well, as you are warming up the water, you accidentally forget that the stove is on and you put your hand right on the burner. Not so smart. So the first thing that happens before you scream or yell or jerk your hand away, the first thing that happens is that the sensory nerves in your fingertips detect a sudden change in temperature. Okay, all of a sudden you're touching something that's extremely hot, extremely more hot, okay, than what your body temperature is. So those temperature regulators, okay, or those sensory nerves, it's the same thing, will detect like, ooh, big change in temperature. But the thing is, those nerves don't understand what to do with it. So they're going to send it to your brain because your brain knows everything, right? It's why it's the brain. Oh goodness, I've had too much coffee or not enough sleep. One of the two. So either way, it sends that sensory input all the way up your arm, into your shoulder, into your spinal cord. Your spinal cord will shoot that message up into your brain. Your brain's gonna go and do that integration process where it says, fingers are telling me there's something really wrong, really hot. I should probably do something about it. So my skin doesn't melt into a puddle because that's disgusting. So your brain will then send a message back down the spinal cord, back down the arm, but instead of going to the sensory nerves anymore, okay, they're now going to go to the motor nerves. So this would be, for example, when we talked about like how neurons and the nerves, okay, actually touch like the muscles. So you did it with your sliding filament theory project, where you had like axon and axon terminal. Those are the things we're talking about right now. Okay, so a lot of times that nerve, okay, that motor output is going to go to a muscle, and that's going to contract a whole bunch of muscles in your arm that cause those muscles to yank your arm away from whatever you're touching. Okay? Now, this sounds like a lot, and it is a lot going on at one time, but it happens so quickly, which is why your nervous system is almost an essential part of the human body at this point. Okay, so even though there's a lot going on at once, it happens extremely quickly, okay, in a matter of like a couple milliseconds even sometimes. Now, we've had our structural classification, which was central nervous system and peripheral nervous system. Okay, we know what nervous system does. This next part here talks about how we classify it based on the function. And really when we're looking at this, we're looking at the peripheral nervous system only. Okay, so functional classification of peripheral nervous system. Now, one of the divisions, so we've talked about this a lot this year, it's kind of like we start with an overarching category like peripheral nervous system, and then we divide it on down. So our first one is the afferent division, with an A. Sometimes this is also called the sensory division. So when you heard me talking about the sensory nerves, those sensory nerves would fall under this division. These are nerve fibers that carry information to the central nervous system. The nerve fibers will also travel away from the stimulus. Okay, and this is actually my memory trick to help me remember that afferent has an A, okay, in it, and that's the one that we're talking about because in the afferent division, we're taking messages from the neuron and we're taking it away from that stimulus. So if we were talking about touching the hot stove, okay, that afferent division is where your message goes from your fingers all the way up to your brain, going away from the stimulus, which is the hot stove, all the way up to the brain. Afferent division. And one of the reasons why I was emphasizing that afferent away, like away from stimulus, is because we also have an efferent division, okay? Because, you know, science likes to be difficult sometimes. And so with your efferent or your motor division, okay, this is where the nerve fibers carry impulses away from the central nervous system, and it gets this name efferent is because it sends signals to the effectors. Okay, and I'm emphasizing the E a little too much maybe, but just so you can actually tell the difference between afferent and efferent. So the effectors are the things that are having the effect. Okay, they're causing the reaction. A lot of times, these are your muscles and your glands. Okay, so in our previous example of where we have the brain is sending a message to your muscles in your arm to pull it away from the stove, that would be the efferent division. Okay, so notice how even when we take a look at the function fits right into these divisions. Okay, so here's a little diagram here. We've got your afferent, so you have a lot of nerve receptors in your cool antivirus, go away. Come negative virus. Awesome. Screencast that. Sorry about that. Okay. Yeah, okay. So what we see, I'm sorry about the interruptions here. So you've got your skin, which has a lot of nerves in it. It's going to pick up all of that information, send it to the brain because it's traveling away from the stimulus, afferent away, okay? It's taking that message to that central nervous system. This is like a cross section of a brain. It looks kind of weird. We're just gonna keep moving over it, alright? That brain says, what do we do, what do we do, what do we do, what do we do, okay? And then it's going to send that message on down, okay? So keep in mind the word spinal cord is here is because the afferent nerve travels up the spinal cord to this brain and then back down, okay? So the efferent nerve is taking it from the central nervous system to the effector, and effectors a lot of times are muscles, but could be things like hormonal glands. Alright, now of course, we can't just stop there. Your efferent division can be divided again into two subdivisions. Oh, I can almost hear you like whining in your head. Get rid of my head. Alright, your two subdivisions. So the first one is your somatic nervous system. The word somatic means body. Okay? So it's going to connect, well, the central nervous system to the good majority of the body, which includes your organs, your muscles, and your skin. These are going to be responsible for your voluntary movements. If you remember, your skeletal muscles are voluntary, which is why we see it under here. The other subdivision is your autonomic nervous system. And the word autonomic, when you say it, it almost sounds like automatic, right? And that kind of helps me remember that this is not the voluntary stuff, it's the involuntary stuff. So this is going to be the part of the nervous system that regulates involuntary things like your heart contracting, your stomach digesting, your intestines making feces, okay? All that involuntary stuff that we don't need to worry about or think about on a constant level. And here we go. Last two subdivisions. There is a infographic, not like like a flow chart, I guess, on the next slide to help put these together too. So with your autonomic nervous system, it's divided into two main parts. You have your parasympathetic, okay, which is used in calming the body and slowing down the heart rate. I remembered this one because in my head, parasympathetic kind of looks like parachute, okay? And I think of like if you were jumping out of a plane, I'm terrified of heights, okay? But if you're jumping out of a plane and you're flying through the air and you open your parachute, it would slow you down, okay? And probably calm you down too, knowing that your parachute's going to work. So parasympathetic slows the body down, slows down that heart rate. The other subdivision of the autonomic nervous system does the exact opposite. The sympathetic nervous system jumpstarts the body. It speeds up the heart rate, okay, which can be important in certain things. These two parts of the nervous system a lot of times are called the fight or flight reaction. Okay, fight or flight. Now, I've got limited time on this, so we're going to go through this really quick, okay? But you can always pause it at any time. So, you see that you have your sense organs here. They're going to send messages through the afferent division, through the peripheral nervous system, to the central nervous system. Notice the blue arrow, okay? That central nervous system is going to say, what do we do about that? It's going to integrate it. Then it's going to send it down the red arrows where it's going to go from the central nervous system back through the peripheral nervous system, okay? If it is since it's going to be like a response, or it's going to have an effect, sometimes I think of afferent as the cause and efferent as the effect, it's going to send it to the efferent division, Okay, and depending on whether it's sending it to a voluntary or involuntary body system, the skeletal system